Good morning. Our chapter number 6, physical change and chemical change is going on. In the first period, we learn about physical change and its examples. Today, we will see the remaining part of this chapter. Now, students, in the first period, we learn about the physical change. In the physical change, what will be happen? We are aware about that the physical properties of the material will be changes. Which are the physical properties will be there? Shape, size, color and state. In the physical change, maybe from these four any property will be changes in that particular change, and this change is a reversible change. Physical change is a reversible change, and no new substance will be formed in the physical change. Afterwards we started our next point, chemical change. In that we learn about the rusting of iron, how rust is different from the iron. Now we will see our next activity 6.6. Here this activity is burning of ribbon, and I will demonstrate you this activity after when school will be start in the laboratory. Now see the activity and understand this. Get a small piece of thin strip. Get a small piece of thin strip or ribbon of magnesium will be available. Clean it tip clean its tip with sandpaper. Clean its tip with the sandpaper and bring tip near a candle flame. Near a candle flame, and it burns with a brilliant white light. Brilliant white light, as shown in figure 6.3. Here you can see in this figure, when the magnesium ribbon, when it burns, that time it burns with the brilliant white light, and when it completely burn, it leaves behind powdery ash material. When it burns, that ribbons, when it burns completely, that time it leaves behind powdery ash type material. And does the ash look like the magnesium ribbon? No, it is different. Now the change can be represented by the following equation. It is a chemical reaction, and it is a chemical equation will be mentioned here. We are taking magnesium ribbon, here magnesium Mg, then oxygen O2, and when a reaction will be occur, oxygen, why it is mentioned oxygen here? Because oxygen is help for the burning. For that purpose here it is mentioned oxygen. Keep in your mind, here Mg, we are burning only magnesium ribbon, but why here mention oxygen? Because oxygen is helpful for the burning of the substance. That's why here it is mentioned O2, oxygen. And then this arrow indicates with what substance will be formed after this reaction, and the substance will be formed magnesium oxide. The powdery ash material is called as a magnesium oxide. Here the equation here are the different from those in mathematics. Here it is different from the mathematics. In these equations of this kind, the arrow indicates becomes, it becomes. No attempt should be made to balance a chemical equation at this stage. Here in this class we are not learning about the how to balance the equations, how to balance the chemical equation. We will learn in the 9th and 10th class. Here only we have to understand these concepts about the chemical equations, how the chemical equation will be performed. Now afterwards, after when we burn the magnesium ribbon, and when we get the magnesium oxide, after that collect this collect the ash material and mix it with small amount of water. Mix it with a small amount of water. We have to take this magnesium oxide and we have to add a small amount of water and stir the mixture aqueous solution well. Stir the mixture well. It have to become aqueous solution. एकदम पाण्यासारखं पूर्णपणे मिक्स झालं पाहिजे. पावडर ॲश मटेरियल त्यामध्ये दिसली नाही पाहिजे, पूर्णपणे मिक्स झालं पाहिजे ते. टेस्ट the mixture Test the mixture with blue and red litmus paper. Blue and red litmus paper. Here your chapter number 5th is there, acid and bases, acid, bases and salt. In that we will learn about how to use blue litmus paper and red litmus paper. Now here two questions are there. Does the mixture turns red litmus blue, and does the mixture turns blue litmus red? I want to mention here, blue litmus paper, it turns red into the acidic conditions, and red litmus paper turns blue in a basic conditions, and when we put that powdery ash material into the water, and when we mix it properly, that time when we test with the when we test with the red litmus paper, that time it turns into the blue, that turns into the blue litmus paper, and that's why we can call as an this solution is a basic in nature. This solution is basic in nature. On the basis of this test, how do you classify the aqueous solution? It is acidic or basic? We can classify it is basic in nature. On dissolving the ash in water, it forms a new substance. It forms a new substance, and this change can be written in the form of following equation. In the form of following equation. When we burn the ribbon, that time one equation is mentioned upper side here. That time which equation will be there? Magnesium, it burns and burns with oxygen and it forms magnesium oxide. And when magnesium oxide it mixes with the water, that time again new equation will be formed. Magnesium oxide MgO plus water H2O. We are aware about that molecular formula of water H2O. Then magnesium hydroxide. Magnesium hydroxide will be formed and the molecular formula is MgOH2. MgOH2. This is the molecular formula of magnesium hydroxide, MgOH2. As you have already learned in chapter 5, magnesium hydroxide is a base. Magnesium hydroxide is a basic material. Magnesium hydroxide is a basic material. So magnesium hydroxide is a new substance formed on burning of magnesium. Burning of magnesium. Magnesium oxide it is formed when magnesium burns, and magnesium hydroxide is another new substance will be formed by mixing of magnesium oxide with water. Magnesium oxide with water. Here in this activity two new substances will be formed. When magnesium burns, that time it found magnesium oxide, and when magnesium oxide mixed with water, that time it found magnesium hydroxide. It becomes in a magnesium hydroxide. Here two new substances will be formed. Now the next activity 6.7. Activity 6.7. This activity also we will do in the laboratory. Now see the activity and understand this. Dissolve about a teaspoonful copper sulfate. A teaspoonful copper sulfate solution, blue vitriol or Nila Totha. Here in Hindi name is there, and blue vitriol or copper sulfate. A scientific name copper sulfate. In about half of a cup of water in a glass tumbler or beaker. We have to take one glass tumbler. In the half of the water we have to mix copper sulfate solution. Copper sulfate. Add a few drops of dilute sulfuric acid to the solution. After this, when solution will be mixed, copper sulfate will be mixed, we have to add few drops of dilute sulfuric acid to the solution, and we get a blue colored solution, which is shown in the figure downside. Copper sulfate solution, blue color solution. We will get the blue color solution. Save a small sample of the solution in a test tube or small glass bottle. We have to take a small amount of this blue solution. We have to keep in the test tube. Separate test tube we have to keep, and drop a nail or use a shaving blade. Shaving blade, we are aware about that, into the remaining solution. And remaining which solution will be there, in that solution we have to put nail or use the shaving blade, and wait for half an hour or so, maybe half an hour or 1 hour we have to wait, and observe the color of the solution. And when we observe the color of the solution, it turns into the greenish color. And compare it with the color of the sample solution saved separately. And when we see in the figure, that time we can see that in the first figure the copper sulfate solution is blue in the color, and dilute sulfuric acid we are added, and when we are putting iron or shaving blade, that time after half an hour or after 1 hour it changes into the greenish color. And iron and some part and blade, the color of the blade also changes. Now here see, do you see any change in the color of the solution? In the color of the solution? Yes, it is shown in the figure also. It will be changes blue into the greenish color. Take out the nail or the blade. which one we are using at the practical, that time practical, suppose we are using nail or suppose we are using blade, that time this particular thing we have to remove it. Has it is changed anyway? Yes, color of that particular material will be changes. You can see in the picture also, when it is inside that the solution and when it is outside at the solution blade, you can see in the screen, on the screen also. The changes that you notice are due to the reaction between copper sulfate and iron. Copper sulfate and iron. The change, why this change will be happen? Because it is the reaction between the two substances, copper sulfate solution and iron. Copper sulfate solution and iron material. The change of color of the solution, the change of color of the solution from blue to green is due to the formation of iron sulfate, is due to the formation of iron sulfate. Here you can downside, you can see here iron sulfate, greenish color material will be there, will be solution will be formed. Formation of iron sulfate, a new substance. The brown deposit on iron nail is copper, and the brownish color you can see on the blade, the brown, it is turns into the brown color, and this brown color, it is the deposition of the copper material. It is the deposition of copper material, and it is another new substance, because we are using here copper sulfate, only copper will be deposited on the blade, and iron sulfate will be formed, new substance, iron sulfate will be formed. And we can write the equation as, here first what we are using, copper sulfate solution, which is blue in color. Here you can see the reaction on the screen, copper sulfate solution which is blue in color, plus we are using iron material plus iron, and after that the solution becomes iron sulfate solution which is green in color, and copper which is brown in color, which is deposited on that iron substance, Here also two new substances will be formed. In this reaction two substances will be formed. Two substances we are using, copper sulfate solution and iron, and after that iron sulfate solution and copper, these two substances, new substances will be formed. Now see the next activity, activity 6.8. Activity 6.8. Take about a teaspoonful of vinegar in a test tube. We have to take vinegar in a test tube. Add a pinch of baking soda to it. Small amount of baking soda, pinch, चिमटभर बेकिंग सोडा त्यामध्ये टाकायचा आहे. Add a pinch of baking soda, खायचा सोडा, बेकिंग सोडा खायचा सोडा आपला, to it. You would hear a hissing sound and see the bubbles of gas coming out. When we put some amount of baking soda in that particular test tube, what happened? We can see the hissing sound. We can hear the hissing sound. Hissing sound, फसफसल्यासारखा आवाज येतो. And the bubbles of gases will be coming out from that test tube. Pass the gas through the freshly prepared lime water. Lime water, चुन्याचं पाणी. Pass this gas through freshly prepared lime water as shown in figure 6.5. And what happens to the lime water? What happens to the lime water? We can see here the change in this test tube as follows. Vinegar, which is also called the scientific name acetic acid, and we are adding baking soda, and scientific name is sodium hydrogen carbonate. Sodium hydrogen carbonate, it is a name, scientific name of the baking soda, and it will be becomes carbon dioxide and plus other substances. When vinegar, in the vinegar, when we are adding baking soda, that time it becomes carbon dioxide and other substances will be formed, and the reaction between the carbon dioxide and lime water as follows. And you can see here the reaction between the carbon dioxide and lime water. Here we can see carbon dioxide, CO2, we are aware about that, plus lime water, CaOH2, and after that, after the mixture of this carbon dioxide and lime water, new substance will be formed, and it is calcium carbonate, CaCO3 plus water, H2O. Here you can see in the setup also, figure 6.5, setup of the pass gas through the lime water. This is a proper setup. You can see there one test tube will be there, first test tube, in that vinegar will be there, and afterwards small amount of baking soda when we are added, that time the gas passes through that particular pipe, passes through that the particular tube, test tube, from that test tube, and from it passes into the lime water. When it passes into the lime water, the gas will be passes from that test tube, it is carbon dioxide, and it is passes into the lime water, and new substance will be formed, calcium carbonate, and water molecules. When carbon dioxide is passed through the lime water, calcium carbonate is formed. Calcium carbonate is formed. When carbon dioxide it passes in the second test tube, that time calcium carbonate will be formed, and which makes lime water milky. Which makes lime water milky. The turning of the lime water into milky is standard test of carbon dioxide. You will use it in chapter 10 to show that the air we breathe out rich in carbon dioxide. We will learn in the respiration chapter number 10. Activity. Now here 6.6, 6.7 and 6.8, all the three activities, when we saw carefully, that time we can found that new substance will be formed. All these three activities, their new substance will be formed. In activity 6.6, you saw that 6.6 to 6.8, you saw that in each change one or more new substances were formed. In each change, suppose it is activity 6.6, 6.7, 6.8, there new one or two or three new substance will be formed. In activity 6.6, the ash was new substance will be formed. When magnesium reburn, it burns, that time it will be prepared magnesium oxide, and when magnesium oxide, and it is ash, powdery ash material, and it is new substance will be there. In activity 6.7, the reaction of copper sulfate with the iron produce iron sulfate and copper. When copper sulfate solution, in that when we are putting iron nail, that time what happen, iron sulfate solution will be prepared, and the copper, from the copper sulfate solution, it will be deposited on that particular iron material. Both of these are the new substances. Copper was deposited on the shaving blade or iron. In activity 6.8, in the last activity 6.8, vinegar and baking soda together produced carbon dioxide. In the last activity 6.8, vinegar and baking soda, they are together produced carbon dioxide, which terms lime water milky. And can you name the new substance formed in this reaction? We are already aware about that new substance, calcium carbonate. Will be formed. Now from these three activities, what we learn from these activities, a change in which one or more new substances is formed is called chemical change. What is the definition of chemical change? A change in which one or more new substances are formed is called chemical change. A chemical change is also called chemical reaction. Chemical reaction. Now here we will see chemical changes are very important in our lives. Why chemical changes are important in our lives? We will see. All the new substances are formed as a result of chemical changes. How? We will see. For example, if a metal is to be extracted from the ore, such as iron from iron ore, we need carry out a series of chemical changes. When the iron, it will be extracted from the iron ore, impure metal materials. Suppose we are getting iron from the soil, that time we have to remove it. Iron material from the impure materials. From that purpose, it is called, that are the chemical changes, that are the chemical reactions are there. For that we are using chemical reactions. Then a medicine is the end product of the chain of chemical reaction. For the medicine, many more chemical reactions will be there, many more chemicals we are using for the preparation of the medicine. These are also called as a chemical reaction. These are also called as a chemical change. Useful new materials such as plastic detergents are produced by chemical reactions. Many useful substances are formed from the chemical changes, like plastic, detergents. These are the useful materials, and it will be formed by the chemical reactions only. Indeed, every new material is discovered by studying chemical changes. By studying chemical changes. Then every new substance, every new material, it is discovered by the studying of chemical change. We have seen that one or more new substances are produced in a chemical change. Are produced in chemical changes. When we see the activity, when we see the carefully activity 6.6, 6.7 and 6.8, that time we can learn that there in each activity there one or two new substances will be formed. In addition to new product, the following may accompany a chemical change. Heat. What will be happen in the chemical change? That 5 points are given here. First one, first what will be happen? Heat, light or any other radiation like ultraviolet, for example, it is given, may be given off or absorbed. In the chemical changes, maybe heat, light energy will be released or it will be absorbed. Heat energy or light energy, heat energy or light energy, it will be maybe given off or maybe absorbed. Second one, sound may be produced. In the 6.8 activity we will learn that hissing sound will be produced here. That's why it is mentioned sound may be produced. Next, third activity, a change in smell by take place or new smell may be given off. When milk becomes sour, that time it gives another different smell, right? We are aware about that. When milk becomes sour, that time it gives different smell. The change in smell may be take place. A color change may take place. A color, we will see, we already learned in activity 6.7 that in that the shaving blade's color will be changed. Then gas may be formed. At the last we will learn about the gas. Carbon dioxide will be prepared in the activity. In that activity, gas may be formed. Now up to this we will learn. Remaining part we will see in the next period.